I wanted to talk to you about calculating the length of a vector. Now, I've talked about vectors in a previous video, and they tell you how to move a point in a specific direction to a new place on an axis or on a grid. Basically, they are described as an X movement and then a Y movement. So as with a normal point, you would sort out your X first and then sort out your Y next. Now, if they're written like this, that means that they're stationary, that they don't move. That is a point that you just mark. Whereas when you see them in a vector, when they're stacked on top of each other, that symbolises a movement. So I know I'm going to take a stationary point, so something that's already occurred, and I'm going to move it to a new place because I've got a movement vector here. Okay, now the numbers that you'll see and the negative positive of them absolutely match onto your axes. So for instance, X travels along this way, so that means that this is a description of left to right because that's the way the x-axis goes. Now if we have a negative x value, that means it's going this way because our negative numbers go to the right, to the left, and our positive numbers go to the right. Whereas here, this is our y value, and y values are described by up and down. So it's up for a positive number and down for a negative number. So here I've got a 3 in the movement of x, so that means I'm going to go along the x-axis, and because it's a positive number, I'm going to move 3 into my positive direction because this is a positive side. And here I've got -2, so my y values would move up and down along here. So I've got -2, so that means that I'd be going down by 2. So let's start by drawing a point. And my point that I'm going to start with is going to be -6, -3. And I'm going to move this in the vector of 5, 7. So that means that my value is going to go 5 to the right. So it's going to go 1, 2, 3, 4, 5, and it's going to be here so far. And then I'm going to move it up by 7 because that's the positive y direction. So 1, 2, 3, 4, 5, 6, 7. Okay, so my actual final point, which if this was labelled A, this would be in the image of A. So I put dash to show that it's my new A. And what they might do is ask you to find the distance between your original A and your A image. Now, this is a diagonal line, so you cannot measure it. You might be able to measure it if it's to scale or if it's in centimetres squared, but it's more likely that you're going to need Pythagoras because if you've travelled this way, you've created a line this way, and if you've travelled this way, you've created a line this way. So actually what we can do is look at the distances that I've travelled horizontally and vertically because that has given me a right angle. So here I've travelled 1, 2, 3, 4, 5, and here I've travelled 7. So now I know that I'm essentially working with a right angled triangle with the shorter side lengths of 5 and 7. So I know that my C squared equals 7 squared plus 5 squared because the Pythagorean theorem was that the two shorter sides, when they're both squared and then added together, equals C squared. So 7 squared is 49, 5 squared is 25, so that gives me 60, 74. So I know that C squared equals 74, and C would be the square root of 74. So let's use my disco calculator. 74, the square root of it is 8.602. So I know that C is 8.602 to one decimal place.